So in this video, I'm going to talk about embedded system. Actually, in this video, I'm not going to cover any part of syllabus, but I'm going to talk about generalized embedded system. Understanding of this video will help students to understand embedded systems that are used in IoT. So let's begin. This is the outline of my video. In this, I'm going to talk about what are embedded systems, components of embedded system, comparison of various software architecture, then applications of embedded system, challenges, embedded software development tools, applications, and future trends. So let's begin with the with embedded system. So what is embedded system? An embedded system is special purpose computer that is used inside a device. So embedded system is designed to perform a specific task. It's a combination of hardware and software that form the component of larger system. So we may have hardware such as sensors, signal conditioners, analog to digital converters, microprocessors, microcontrollers, drivers, output drivers, then actuators, etc. In a hardware part, and then we require some set of softwares to work with those hardwares. So combination of these hardware components and softwares uh, combinedly called as a embedded system. So, what are the components of embedded system? As I said, embedded hardware, it mainly consists of microcontroller or any microprocessor with various peripheral ICs. So, it may include microcontroller, microprocessor along with its I/O interfacing capabilities. Then we have embedded RTOS. This is all intelligent devices that perform complex functions, have an embedded operating system inside. The next is device driver. So this is the interface between hardware and software. So the software that acts as a glue between operating system and the peripheral device is called as a device driver. Next one is a communication stack. So if the embedded system is capable of communicating to external world, it has a communication software stack running on the top of operating system. So it could be protocols related with the Wi-Fi, Zigbee, Bluetooth, etc. Then we may have embedded application. It perform the predefined function of embedded device. Actually the application is nothing but a software that provides required services to the users. Now here I am going to compare various operating system, various software architectures. So those software architectures are round robin with interrupts, function queue scheduling, and real time operating system. I am going to compare those four with respect to priorities available, worst response time for task code, stability of response when the code changes, and the simplicity. So in round robin, the priorities are not available. Worst response time is execution time for all the task codes. Stability is poor for round robin, and it is very simple. Next is round robin with the interrupts. Priorities available. So interrupt routines in priority order, then the task code in priority order. So that means priorities are available with round robin with the interrupt. Then worst time response. So total execution time for all the task code plus execution time for the interrupt routines. Next is stability. Stability of this round robin with interrupt is good for interrupt routines, poor for task code, and it is again quite simple in use. The next is function queue scheduling. Priorities interrupt routine in a priority order, then all the tasks at same priority. Next is worst response time for task code. So execution time for the longest function plus execution time for the interrupt routines are available with the function queue scheduling. In a function queue scheduling, relatively good stability we can obtain, and the simplicity, if you compare, it must deal with data shared between interrupt routine and task code. In RTOS, routines in a priority order, that means priorities are available. Next, response time is 0. Then stability is very good for RTOS, and the complexity or the simplicity, we can consider this RTOS is a little bit complex as compared to other or previous three software architectures. This is the toolchain for embedded software. We actually call this as ID integrated development environment, in which we can write the programs in C or in C language, C++, or in assembly language. If I write the program in C or in C++, it has to be passed through cross compiler. Then cross compiler will generate its ASM file. Then it goes to object file may be in any format such as obj. Then such a files are given to the linkers, where all other sub components of the programs are combined and located. So linker will generate a machine code. This machine code is given to a single executable file. So this would generate a hex format, or you can say the image, a single executable image that can be burned on the ROM of any processor or controller. On the other hand, if you write the program in assembly language, so first of all we need to do the target of the assembly language. Then again we need to go for cross compiler. Then again object files, and rest of the process is same for assembly also. So once the executable file is generated, we can load it on a microcontroller or on a microprocessor of any embedded system. Next point is challenges in embedded system. In that, first is precise engineering and design. Implementing low cost embedded system is another challenge. Ensuring high performance of the system is another challenge. We have to select the chips very carefully. They have to be cost effective. They have to be a low power consumption units. We have to ensure the efficiency also. So in short, the challenge is to provide affordable high integrated devices meeting a stringent requirement for safety, security, reliability, availability, and at the same time keeping the cost low. Now let's talk about the applications of embedded system. First one is automatic teller machine ATM. Then you can find the embedded systems are being used in cellular telephone networks and telephone switches. Embedded systems are used in handheld calculators also. These are also used in household appliances including washing machine, television set, microwave oven. Another scenario of application, here you can find digital camera suite, DVD record suite, set-top box, printer, etc. are being making use of embedded systems. These are the applications. So some more applications, multifunction wrist watches. So you can find some smart watches being provided by Samsung, then Apple, then Xiaomi. They provide some smart watches, wearable watches, which can be acts as some kind of sports gadget, which can keep a track of your breathing. It can keep a track of your health. They are having communication technologies like Bluetooth and Zigbee enabled devices. So medical equipments are another application of embedded system. You may find embedded systems are being used in programmable digital assistants. Measurement equipments like oscilloscope, logic analyzer, and spectrum analyzers are the examples. PLCs are also making use of embedded system. Now, embedded as a globe, you may find use of embedded system in automobile industries. You may find it in offices. You can find it in medical and healthcare industries. Embedded system find a wide variety of applications in aerospace and defense department. Embedded systems play a vital role in instrumentation and industrial automation. On the other hand, you may find they are helpful in central office equipments. They may be used in wireless communication. Embedded systems are used in IP network, mobiles, and home appliance, home televisions, etc. So, if you compare those application areas, you may find it in home appliances, audiovisual equipment, entertainment, education, uh, personal information appliances, communication equipment, transportation related facilities, factory automation, electrical equipment, medical equipment, commercial systems, miscellaneous, and others. So you may find the different percentage of the area who are making use of embedded system. So this is just another kind of application, so we may skip to the next slides. Now, future trends: adaptive cruise control, telemedicines, security, telematics, Bluetooth applications. So Bluetooth as an application of embedded system can be used in a variety of areas. Here you may find Bluetooth is being used in a MP3, data exchange with the mobile phones and games, voice headsets, printer may be connected with the Bluetooth, internet is also making use of it, camera control, picture sharing, voice hands free. So these are just an applications of Bluetooth. So let us move on to the conclusion. The world of embedded system is a dreamer's paradise with unlimited possibilities. It makes controlling all the system around just by a simple gesture, and the thing respond to you if it was some magic. As a microprocessor, as a microprocessors are becoming smaller and cheaper, more and more products are becoming smart with microprocessor embedded in them. So if you got any questions, you can find the answers by watching those videos that I have created here. So thanks for watching this video.